Hi, Chris Kuzmal here. We're now talking about quantifying logical sentences. So far what we've done is we've introduced the idea of a relational logic, which includes the concept of a relation and the concept of a variable, but we haven't talked about what those variables mean or really how to use them more robustly. And they are used more robustly when we introduce the idea of a quantifier. So let's do an example. Let's start off with the premise that says that leopard is either a cat or a ball, or I guess this logical sentence allows for leopard being both a cat or a ball, depending on what leopard's eaten, that might be true. And so this vertical bar here is the disjunction operator, don't forget. And so we're just saying that leopard's a cat or a ball. No problem. This seems like we've expressed it very efficiently. It's a very good thing. That's lovely. What if we say, wait, hold on now. Dasha also is a cat or a ball. Dasha does not want to be left out of this. Dasha is quite insistent that we also assert that Dasha is a cat or a ball. And so, and it's true that Dasha is a cat or a ball as well. So, this is a more complete statement, but the balls are not real thrilled either until they're included. And so we include them both. And actually now we've included everything. All right, fine. Everybody's a cat or a ball, okay? And geez, it would have been nice to just say that. So now we can by introducing the universal quantifier X that says that, for all X, it's a cat or a ball. And that is what the universal quantifier does. It allows us to transform this rather complex sentence above to this relatively simple sentence below. Now, it does introduce the scary upside down A, though, so, life is never perfect. We'd also like to be able to say that, well, look, something in our world is blue. In fact, as it turns out, two things in our world are blue. I forget whether leopard or dash is blue, and I forget whether ball one or ball two is blue, but I know one of each of them actually is blue. And we can write the sentence above as just there is some y such that y is blue, okay? And so here we wrote a backward z instead of an upside down a, and that corresponds to these disjunctions, these or operators, as opposed to the conjunctions that happened when we were making this set of logical sentences. So those are the two quantifiers, the universal quantifier, the upside down a, and the existential quantifier, the backward z. And so let's generalize this and say, suppose one of the objects satisfies the property P. If we have a signature, that has the set A, B, and C in it, and we have that unary operator P, then all we have to do to express the sentence at the top of the screen that one of the objects satisfies the property P is write, there exists an X such that P of X. That would be equivalent to saying P of A or P of B or P of C. It'd be the equivalent of saying PA or PB or PC if we were to go back to propositional logic. But if we wanted all of the objects to satisfy the property P, we would replace the existential operator, the backward Z, with the upside down A, and we'd replace all of the disjunction operators, the vertical bars, the ors, with ands. And so that's what the red is. And again, I have to point out that for several of these slides, this PB should actually be PC. Then, if we want to add another object to our set of object constants, we would have to modify the two logical sentences below on the bottom to accommodate that specific object. But our universally quantified or existentially quantified sentence does not have to change, even though we've changed our included set of object constants. And so if you have the question, how do we write a logical sentence using quantifiers and variables? One example, the simplest example I can think of is to say there exists an X such that P of X. An equivalent logical sentence to that, assuming we have the signature ABC with P and 1, the equivalent sentence to that would be just to say P of A or P of B or P of C. And an equivalent propositional logical sentence would be the disjunction of a set of object constants that correspond to each one of our relations as related to each of our objects.